Welcome back to part 4 of your Unit 4 test review. This is our last video. Number 16, in each bag of Dum-Dums, there are 3 more cherry than root beer. The relationship is represented by the table. Let X represent the number of root beer lollipops. Let Y represent the number of cherry lollipops. And then we've got our XY table. Which statement is true? A, the equation of the line is y equals 3x, which means 3 times x. B, the y-intercept of the line is minus 3 or negative 3. C, the y-intercept of the line is 3. Or D, the equation of the line is y equals x minus 3. Go back to the problem and read it one more time. In each bag of Dum-Dums, there are 3 more cherry than root beer. When I hear those words 3 more, it automatically makes me think plus 3. If there's always 3 more cherry than root beer, then I could take how many root beer I've got, add 3, and that should be how many cherry I've got. So looking at my table, I want the connection between x and y. So notice x is written on top of y this time. The table's a little different. So 3 became 6, 4 became 7, and 5 became 8. Right away, I notice that pattern plus 3 works every time. 3 plus 3 is 6, 4 plus 3 is 7, and 5 plus 3 is 8. So the equation of this table would be that y equals x plus 3, because we took each x value and we added 3 to it to get the y value. Because I know that this is the equation, x plus 3, I can look at the statements that were written about equations, and if they don't say that, then they can't be true. A says the equation should be y equals 3x, which means 3 times x. If I did 3 times 3, I would get 9, not 6. So the equation 3 times x does not work. D says the equation of the line is y equals x minus 3. And we already know that doesn't work because 3 minus 3 would be 0, not 6. 4 minus 3 would be 1, not 7. And 5 minus 3 would be 2, not 8. So D is also incorrect. We know that the equation is y equals x plus 3. When equations are written in the form of y equals x plus b, that number on the end that's written where plus b is very special. It represents the y-intercept. You can also think of your y-intercept as like the rule from your table. Our y-intercept here from this equation is plus 3 because the plus 3 is written in the same spot as plus b, which we know represents our y-intercept. I also know that my y-intercept would be 3 because the y-intercept is where x is 0. If x were 0, my rule is plus 3. That makes y 3 here. So the y-intercept of the line is 3, and the best choice here is answer C. Number 17 says which line appears to contain all the ordered pairs in the table. So remember, these ordered pairs, these rows in the table, are just points. So 2, 1 in the table is like 2, 1. That's going to be a point on the graph. Switching colors for my next point. 0, 0. That's x coordinate 0, y coordinate 0 is going to be another point on the graph. -2, -1. I'm going to do each one in a different color so that it's really easy for you to see the difference between them. And the last point is going to be -4, -2. So I'm going to start with that one since I'm holding the red pen right now. When we want to plot points, ordered pairs, we start at the origin. Because my x value is a -4, I need to go left 4. 1, 2, 3, 4. Because my y value is a -2, I need to go down 2. 1, 2. Right away, just by plotting this -4, -2, I notice it's not on the blue line, so I can eliminate choice A. Let's look at choice C. From my origin to plot -4, -2, I would go left 4, 1, 2, 3, 4, and then I would go down 2. Now I know it was right on the end, but that point, -4, -2, is on the blue line. So C might be our correct answer. Since we got a point on the line, let's check another one. Let's check for -2, -1. So from my origin, when x is -2, I would go left 2. When y is -1, I would go down 1. And sure enough, the point -2, -1 is a point on the line for C. So now I can check for 0, 0. 0, 0, well, that's just my origin. So from my origin, I plot a point, and that is on the blue line. The last point I need to check for is 2, 1. +2 for my x, +1 for my y. So from my origin, when x is positive, I go right 2. Because my y value of 1 is also positive, I go up 1. And sure enough, the ordered pair 2, 1 is a point on the blue line in answer choice C. So because this line in C contains all of the ordered pairs in the table, C must be the best choice. If you wanted to really quickly prove to yourself that B and D were wrong, pick a point in the table and plug it in and make sure it doesn't work. I've got the blue pen out right now, so I'll check for -2, -1. So from my origin, I go left 2 and down 1. Oops, I actually have the purple pen. Let me undo that. From my origin, I'll go right 2 and up 1. So right 2, up 1. Is the ordered pair 2, 1 on the line for B? Nope. So now let's check for D. From my origin, I go right 2 and up 1. Is that point on the line for D? No. So just proving to ourselves that C is the best choice here. Number 18 says, which table represents y equals 5/2 x, which really means 5/2 times x, or 5/2 times x. When the number is written in front of x like this, it means we are multiplying. So what we want to figure out is which table, when we take the x values and multiply them times 5/2, which one gives us the y value. So we'll go through each table and we're going to figure out which one works every time. Now we have to be careful because something they'll do is they'll give us a table where the rule works sometimes. It'll work for like the first row or the last row, but it won't work every time. So it's really important if we think a table is correct, we can't just circle it after we check one row. If we think something is correct, we have to check every single row to make sure that it works. So what we're going to do is we're going to type in this part of the equation with the x in it. So we're going to type in 5/2 times x. And to check each table, we're going to take the x values and plug them into Desmos. So I'm going to start with A. My first x value in A is -10. So I'm going to plug in here that x equals -10. And I want right here for Desmos to tell me that 5/2 times x, or 5/2 times -10, is going to equal -25. So let's type in -10. And sure enough, Desmos is telling me that it's a match. So this first row works. So now I need to check for the next x value. The next x value in my table is -8. And when I plug that in, I should get a y value of -20. So I'm going to delete that and I'm going to type in that x equals -8. And when I do that, Desmos is telling me that y equals -20. It's another match. So now I need to check my last x value from the table, which is -6. When x was -6 in the table, y should be +15 according to the table. When I plugged -6 into Desmos, Desmos is telling me that the answer is -15, and that is not a match. So A seemed like it was going to work. The first two were correct, but the last row did not work. So we need to eliminate choice A. So let's look at choice B, table B. Same equation, so we can keep the 5/2 x in here, but now our first x value that we're testing is 0. So I'm going to plug in x equals 0, and sure enough, y equals 0. That's a match. Now I'm going to plug in my next x value, which is 4. And Desmos is telling me that y should equal 10, but the table says -10. So that is not a match. So now I can eliminate B and move on. Again, I can keep the equation because we're testing this same equation every time, and we're just changing the x values from the table to see which one matches. So this first one here, x is -2. We want the answer to say -5. When I type in x equals -2, Desmos tells me that y equals -5, so that's a match. My next x value is +2. So when I type in x equals +2, I want it to say +5, and sure enough it does, so that's a match. My last x value in the table is 6. When I plug it in, I want Desmos to tell me that y equals 15. When I plug in x is 6, sure enough, Desmos tells me y equals 15. So that is a match. So all 3 rows of the table in C were correct. So choice C is our best choice. If you wanted to make sure that D is incorrect, type in -4 for x. Y is supposed to equal +10 according to the table, but according to Desmos, it should say -10. So because this is not a match, I can for sure eliminate choice D, and I know that I got this answer correct. All right, question 19. Laura is 6 years younger than her sister Jessica. Let x equals Jessica's age and let y equal Laura's age. Which equation represents this relationship between Laura's age and Jessica's age? So I think it's really important to point out that y is Laura's age, and Laura is 6 years younger than Jessica. X represents Jessica's age. And Jessica is going to be 6 years older than Laura. So if Jessica was 10 and Laura is 6 years younger, 10 minus 6 would be 4. If Jessica was 15 and Laura's 6 years younger, 15 minus 6 would be 9. So it sounds like the equation, what the problem is telling me to do is to take x, Jessica's age, and I need to subtract 6 from it. Because if Jessica's older and Laura's 6 years younger, Jessica's age minus 6 would tell us Laura's age. So x minus 6 is going to equal y, but we know that we always write our equations in the form of y equals. So if x minus 6 equals y, you can just flip those around. Y is equal to x minus 6. So which equation is that? That would be choice B. Choice A says 6 times x. Laura is not 6 times younger than her sister Jessica, so you're not going to pick choice A. Choice C says y equals x plus 6. You just got to be careful here. X is Jessica's age. So again, if Jessica was 15 years old and I wanted to figure out Laura's age, I would want to subtract 6 from Jessica's age, not add 6. D says y equals -6 times x. We're not going to multiply -6 times Jessica's age to get Laura's age. That doesn't make any sense here. So the only choice here that makes sense for this scenario is choice B. And that is it for our Unit 4 test review. Go ahead and study the rest of your notes and prepare for your test.